Hi guys, so in today's video we'll be continuing with pre-calculus concepts, this time chatting a little bit about factor theorem. So first, before we get into it, understand that factor theorem comes from, or at least we'll be using remainder theorem within factor theorem, so make sure that you do check out that remainder theorem video. But let's first look at a bit of an example, right? So if we talk about the factors of 10, we obviously are chatting about the numbers 1, 2, 5, and 10, right? So all of these numbers, obviously in their factor pairs, 2 and 10, and 1 and 10 and 2 and 5, sorry, right? We know that the products of those pairs obviously gives us 10, right? But we also notice that I can divide 10 by each one of these numbers and there will be no remainder left over. For example, 10 divided by 2 gives me a perfect answer of 5. In the same way, 10 divided by 10 gives me a perfect answer of 1. No remainders. So factor theorem sort of stems from that. We then realize that if something is a factor, right, there will not be any remainders when I divide, like for example here, the 10 by that factor. Okay, so that's where factor theorem sort of stems from. Looking at maybe two definitions that we should know. The first would be that if f of negative b over a is equal to 0, right? And from our previous video on remainder theorem, we know that this is just the remainder, right? If my remainder is equal to 0, then it must be true that ax plus b is a factor. Right, so if we divide and the remainder is 0, then ax plus b is a factor. And similarly, right, if ax plus b is a factor, right, they give us that knowledge, then we know the remainder will equal to 0. Okay, right. So those are just two sort of different approaches on factor theorem, or at least two definitions that we need to know. And this will then help us answer questions. Very, very important, I would say, especially for cubic functions in calculus. So be sure that you do understand factor theorem, at least, at the minimum. Okay, right. What I'll be doing next then is doing some examples of how we can use factor theorem to possibly solve questions and find certain variables and whatnot. Okay, so before I get into my example, let's just look at a trinomial. A trinomial like x squared minus 5x plus 6. Right, so let's say this is the function we are given. Quadratic function, basically a parabola. Right, is a parabola. So if I want to test whether x minus 2 is a factor of this function, according to my definitions that I provided before, f of negative b over a should equal 0, right? With x minus 2 being where I get my a and b values from. So let's test it out. Negative, and my b value over here is negative 2, all over a, with my a value being 1. We know negative times a negative is positive, so that is just positive 2. So let's test it out. Positive 2 squared minus 5 times positive 2 plus 6. 2 squared is 4, minus 5 times 2 is 10, plus 6. 4 plus 6 is 10, minus 10 is 0. So therefore we can safely assume, not even assume, say that x minus 2 is or must be a factor of my function that I'm given. Okay, so this is basically how factor theorem works. Okay, so the example behind me says, given x plus 2 is a factor of f of x being a cubic function, 3x cubed plus px squared minus 2x plus 8. Solve for p. Right, so we're going to use factor theorem now to determine what p's value is. So, knowing that we are dealing with a factor, we know that f of negative b over a should equal 0. My remainder should be 0 when I divide f of x by x plus 2. So first we are going to determine what that substitution value is. We know that's ax plus b. So f of negative b, which would be negative 2 over a, which is 1. So just negative 2. So I know when I substitute in negative 2 into f of x, I should get an answer of 0, which now means that I can create an equation to solve for my p-value. Okay, so let's do that. We know that if I say 3 times negative 2 cubed plus p times negative 2 squared minus 2 times negative 2 plus 8, I should get a remainder, a value of 0. Right, and now I see p is my only variable, so I can solve for it. Okay, I will say negative 2 cubed is negative 8. 3 times negative 8, negative 24. Negative 2 squared is positive 4, so that leaves me with positive 4p. Negative 2 times negative 2, positive 4 plus 8 equals to 0. I'm going to leave 4p on this side, take everything else over, but I'll first just add it up. 4 plus 8 is positive 12. Positive 12 minus 24 is negative 24, negative 12. Taking it over leaves me with positive 12. To get p alone, I divide by 4, and I'll find that I get p to have a value of 3. Right. So that is how I now used factor theorem to solve for p. Okay. Factor theorem has many other applications, but the main one, like I said, comes in when we deal with cubic functions in calculus. So please keep an eye out for that. Other than that, that is factor theorem.